Traditionally, industrial control systems and SCADA environments have been air-gapped from the internet and IT networks, operating solely within the domain of obscure protocols within the operation technology or OT networks. However, with the rise of industrial IoT, devices such as connected sensors, electronic meters, and manufacturing robots, along with the demand for efficient systems, remote accessibility, and smarter infrastructure, traditional ICS environments are merging OT networks with IT networks, exposing them to an increased risk of attacks. The Fortinet security fabric is adapted for and highly suited to help protect critical ICS environments. To demonstrate its effectiveness, we're going to use an example of one of the most common and critical infrastructures, a hydroelectric dam. Let me introduce you to the elements of an ICS network. The Human Management Interface. Inside the process network is the HMI, a monitoring station for the human operator to keep an eye on the key components of the system, ensuring all the systems are functioning as expected. SCADA Master. The SCADA Master is a trusted node that controls the entire process. It collects data from all the components and maintains system integrity. Fortigate. The Fortigate provides active network control and security enforcement. The Fortigate can leverage the power of the security fabric to protect the ICS environment in a powerful and automated way. PLC is an economical, flexible, and configurable controller that is used to control field components such as the various valves, pumps, and sensors. It receives instructions from the SCADA master and executes commands to the field network. Our fabric-ready partner, Nozomi SCADA Guardian, is placed in between the process and control networks. The SCADA Guardian passively monitors and performs deep behavioral analysis of the SCADA traffic. All of this works to control and manage the critical infrastructure of the hydroelectric dam. Let's look at the typical activity of a hydroelectric dam. We can see the two bodies of water here. On the left is the lake, and on the right is the reservoir where the water is stored. When there is a demand for electricity, the PLC commands the valves to open, which causes the water to flow down from the reservoir into the lake due to gravity. This causes the turbines to spin, which in turn generates electricity. When the reservoir is almost empty, the sensors within the reservoir communicate the water level to the PLC, which then commands the valves to close. This prevents the flow of water and thus no electricity is generated. At times when the demand for electricity is low, the PLC can command the pump, which uses excess generation capacity to pump the water from the lake back into the reservoir. This is the typical scenario of a water dam. Let's go over some attack scenarios on how the Fortinet security fabric can protect the ICS environment from threats. Our first scenario is a common way attackers gain visibility into the network to find vectors of attack. An unknown client that has appeared on the network who decides to perform a port scan using the Nmap tool to scan for open ports on the PLC. This would normally result in the attacker discovering potential vulnerabilities. We can see that the Nozomi SCADA Guardian has a new alert identifying the unrecognized machine in the network, providing us with the visibility of trusted nodes and protocols. Leveraging the Fortinet security fabric, this information is sent over to the Fortigate, in which a security policy is automatically created which has blocked the unrecognized node in question. This has effectively stopped the attacker in his tracks. In our second scenario, we have a known node within the Trusted Process Network subnet, the Human Machine Interface, or the HMI, that attempts to perform unauthorized actions. Here is the console of the HMI in the process network. A trusted operator attempts to execute unauthorized commands in an attempt to reprogram the PLC in an unverified manner. We can see that the SCADA Guardian has a new alert stating that a new SCADA function code is detected. Again, leveraging the Fortinet security fabric, we can see that a new policy has been generated in the Fortigate which has blocked this connection. In our last scenario, we have an advanced tailored malware or a zero-day that is modifying the industrial process in a subtle way. The malware is running inside the SCADA master, is using approved libraries and commands, but is modifying the PLC status to drive the system into failure. In this example, let's demonstrate what can happen if the attack was carried out without the security protection of the Fortinet security fabric. We will launch an advanced malware attack on the PLC. This virus will scan the behavior of the PLC and consequently infect the PLC by sending malicious commands. We can see that the infection has been successful. The valves and the pump are now behaving erratically and the reservoir water levels are exceeding standard limits. This can cause tremendous amount of damage to the infrastructure. On the SCADA Guardian, we can see that the alerts were generated for this malicious activity. However, due to the lack of security integration, this activity was allowed. Now, let's go ahead and enable the Fortinet Security Fabric Ready integration. This time, if we attempt to run the virus, it will again scan for the PLC's behavior. But when it attempts the infection, we observe that the system fails to infect the PLC and the virus crashes. It is important to note that the regular operations of the PLC are maintained, whereas only the bad traffic generated by the virus was blocked. This is possible due to the granularity that the Fortigate has in its ability to enforce active network traffic control. This demonstrates the ability of the Fortinet Security Fabric to provide advanced security and threat protection for critical industrial control system environments in a broad, powerful, and automated way to protect it from the increased risk of attacks while ensuring integrity of regular operations.